Welcome to Joey's Dynamic Programming tutorial. In this video, let's look into a Leetcode problem, super ugly numbers. I bet that this problem will be fun to solve and will definitely up your game when it comes to cracking technical interviews. Before I move to the problem statement, I humbly request you to subscribe to my channel and hit the bell icon next to it because that way you will get notified whenever I release videos like these in the future. Now let's check out its problem statement. An array of prime numbers is given to you. The numbers in this array of primes are 2, 7, 13 and 19. Along with this array of primes, you are given a number n. All you need to do is find the nth super ugly number. A super ugly number is a positive integer whose prime factors are in the given array of primes. For example, 2 will be a super ugly number, but neither 3 nor 5 are going to be the super ugly numbers because they are not present in the array of primes given over here. Now let's start solving this problem using the classic dynamic programming approach. I have placed the array of primes here. N for us is 12, and so beneath this array I have created another array of n plus 1 integers which will give us the final 12th super ugly number. Let's do some brainstorming here. Let me write down a few super ugly numbers so that we can find out some pattern that will help us solve this problem using dynamic programming. So there is 1, the first super ugly number, 2, 4, 7, 8, 13, 14 and 16. And let's just stop right here for now. Note that these super ugly numbers have been made from the numbers present in the array of primes. 1 is the universal super ugly number, so we won't look into it. 2 is the first prime number in the array of primes, so it will be our second super ugly number. Look at the next super ugly number, 4. If I multiply 2 from here with the second super ugly number, then I get 4. It turns as our third super ugly number. Now if I multiply this 2 with 4, then we get 8, which is another super ugly number. But observe that we have 7 which is less than 8, so it takes the precedence. When I proceed ahead and multiply 2, the second super ugly number, with 7 and 8, then I get 14 and 16, which become the next super ugly numbers. But before that, we got 13 over here. So after 8, 13 becomes the next super ugly number, and then 14 and 16 appear in the line. Based on this observation, let's proceed to solving this problem using dynamic programming. So first I create an array of multiples here next to our array of primes and fill it with 1. The first super ugly number is always 1. So let me put 1 in the cell at index 1. Now let's move to the second cell at index 2. For this cell, we are going to iterate through the array of primes first. The first prime number in the array is 2, and in the first cell of the array of multiples, we have 1 stored. So I pick this one and look at the value at index 1 in the solution array. The value here is 1, so I multiply 1 with 2. The value comes out as 2, and thus I populate 2 in the cell here. If you remember, we did this moments ago during our brainstorming session. Then I move to the next cell in the array of primes. Here the value is 7. I'll look at the value in the corresponding cell in the array of multiples. The value is 1. So I will multiply 7 with the value in the cell at index 1. 7 multiplied with 1 gives me 7. We have 2 already present here, so what do you think the second super ugly number should be? 2 or 7? 7 is too big to be the second super ugly number, hence for every cell we choose the minimum. The minimum between 2 and 7 is 2, so 2 stays, 7 gets eliminated. Now we move to the third number in the array of primes. The number is 13. Let's multiply it with the value at index 1, as it is the value that exists in the corresponding cell in the array of multiples. The value in the solution array at index 1 is 1, so the multiplication result comes out as 13. Between 13 and 2, 2 is minimum, so it stays. Similarly, I will multiply 19 with 1, which will give me 19, and again it is not less than 2, so 2 stays. Array of multiples has a lot of significance here, as it holds the indexes of the subproblems. Now using 2 from the array of primes, we got the second super ugly number, hence I increment the index here by 1. You are going to understand in a moment why I did so. We move to find the third super ugly number. 2 is the first prime number, and in our array of multiples I have stored 2 in the corresponding cell. Check out the value at index 2. It is 2. Our second super ugly number, 2 multiplied with this 2 gives us 4. So I populate 4 in this cell. Now I move to 7, the second prime number. The index stored in the corresponding cell in the array of multiples is 1. At index 1 we have 1 stored. 7 multiplied by 1 will give us 7. It is not less than 4, so 4 stays and 7 goes out. I move to 13 now, the third prime number. The index stored in the corresponding cell of the array of multiples is 1. At index 1 we have 1 stored. 13 multiplied by 1 will give us 13. It is not less than 4, so 4 stays and 13 goes out. I move to 19 now, the fourth prime number. The index stored in the corresponding cell of the array of multiples is 1. At index 1 we have 1 stored. 19 multiplied by 1 will give us 19. It is not less than 4, so 4 stays and 19 goes out. You see why I incremented the multiple over here by 1? If you haven't understood it, then try linking it with what you saw during brainstorming, and you can watch that segment again. Also, since the prime number 2 has given us the current super ugly number, hence the value in the corresponding cell gets incremented by 1 again. Now let's find out the next super ugly number. We use 2. We check the value at index stored here. The value at index 3 is 4. So the value comes out as 8. I populate 8 in this cell. Now I move to 7, the second prime number. The index stored in the corresponding cell of the array of multiples is 1. At index 1 we have 1 stored. 7 multiplied by 1 will give us 7. This time it is greater than the value stored, so 7 replaces 8. I move to 13 now, the third prime number. The index stored in the corresponding cell of the array of multiples is 1. At index 1 we have 1 stored. 13 multiplied by 1 will give us 13. It is not less than 7, so 7 stays and 13 goes out. I move to 19 now, the fourth prime number. The index stored in the corresponding cell of the array of multiples is 1. At index 1 we have 1 stored. 19 multiplied by 1 will give us 19. It is not less than 7, so 7 stays and 19 goes out. Also, since we got this super ugly number using 7, so we will increment the index in the array of multiples by 1. Hence, the value here becomes 2. This 2 indicates that the next super ugly number, whose prime factor is 7, will be derived by multiplying 7 with the super ugly number at index 2. Based on this logic, let's fill the values in the subsequent cells. Let's move to finding the fifth super ugly number. We move to the first number in the array of primes, which is 2. We have the index 3 over here. The value at index 3 is 4. 4 multiplied by 2 is going to give me 8. So I populate 8 in this cell. Then I move to the next number in the array of primes. I have 7 here and the index over here is 2. Value at index 2 is 2. 2 multiplied by 7 is going to give me 14. Now 14 is not less than 8. So 14 will be eliminated and 8 stays. The next number in the array of primes is 13. Here the value is 1. At 1 we have 1. So 13 multiplied by 1 is going to give me 13. And since 13 is bigger than 8, 8 is less than 13. Hence 13 gets eliminated and 8 stays. We move to 19. Here the index is 1. At index 1 we have 1. So 19 multiplied by 1 is going to give me 19. 19 is also greater than 8. It's not less than 8. So what I'm going to do, I'm going to eliminate 19 and 8 stays. Since we have got this super ugly number from 2, hence in this case we are going to increment the value in the corresponding cell by 1. So this 3 becomes 4 now. And we move to finding the sixth super ugly number. We are going to start from here again. The first prime number, which is 2. Here the index is 4 in the corresponding cell in the array of multiples. At 4 we have 7. So 2 multiplied by 7 is going to give us 14. In that case I am going to populate 14 in here. Now we move to the next number in the array of primes. We have 7 over here and the index here is 2. Let's check the value at index 2. It is 2. 2 multiplied by 7 is going to give me 14 again. Now 14 is already present here, so it is not replaceable with 14. That doesn't make sense at all. We move to the next number in the array of primes. It's 13. The index here is 1 in the corresponding cell. At 1 we have 1, so 13 multiplied by 1 is going to give me 13. So since 13 is less than 14, hence it is going to replace 14 and I populate 13 in this cell. We move to the last number in the array of primes, 19. The index is 1, value here is 1, 19 multiplied by 1 is going to give me 19. Now since 19 is not less than 13, hence 13 stays and 19 gets eliminated. Now we got this super ugly number using 13, hence what we are going to do, we are going to increment the index in the corresponding cell in the array of multiples. So this one changes to 2. We move to finding the seventh super ugly number. Now we are going to start with 2. Here the index is 4. Value at index 4 is 7. 7 multiplied by 2 is going to give me 14. So I populate 14 in this cell. Now we have 7 as the second number in the array of primes. Here the index is 2. At 2 we have 2. So 7 multiplied by 2 is going to give us 14 again. 14 is already present over here, so we are not going to replace it, right? We move to this 13. Here the index is 2 in the corresponding cell. At 2 we have 2, so 13 multiplied by 2 is going to give me what? 26. Now 26 is no way less than 14, so 26 gets eliminated and 14 stays. We move to the last number in the array of primes, which is 19. It is going to be multiplied with 1. So 19 is again not less than 14, so 19 gets eliminated and 14 stays. Now we got this 14 using 2, so what we are going to do, we are going to increment this index by 1. But wait a minute, when we looked into this prime number, we also got the value as 14 because here the index was 2. At 2 we had 2. When we multiplied 2 by 7, we got 14. So that means we will have to increment this index by 1 as well, because this super ugly number is being given by these two prime numbers. Hence this 2 will change to 3. Let's move to determining the 8th super ugly number. We start with 2 over here. Here the index is 5. At 5 we have 8. So 2 multiplied by 8 is going to give us 16. So I populate 16 directly in this cell. The second number in the array of primes is 7. Over here I have the index as 3. At 3, let's see what the value is. It's 4. 7 multiplied by 4 is going to give me 28, which is no way less than 16. Hence 28 gets eliminated and 16 stays. 13 over here will be multiplied with the number at index 2, which is 2. So 13 multiplied by 2 is going to give me 26, which is also greater than 16. Hence 26 gets removed and 16 stays. Now 19 will be multiplied by 1 because we have the index over here is 1. So I'll get 19, but it's also not less than 16. Hence 19 gets eliminated and 16 stays. So I got this super ugly number, 8th super ugly number, using this number from the array of primes, which is 2. So I'm going to increment this 5 to 6. Let's find out the 9th super ugly number now. We will start with 2. Here the index is 6. At 6 I have 13. So 13 multiplied by 2 is going to give me 26. So I populate 26 in this cell. Now I move to the second number in the array of primes, which is 7. The index in the corresponding cell is 3. At 3 I have 4. So 7 multiplied by 4 is going to give me 28, which is greater than 26, and hence it gets eliminated. I move to the third number now. 13 will be multiplied with the value at index 2, which is 2. So 13 multiplied by 2 is going to give me 26. Now 26 is already populated over here, so no way it's going to replace it. I'm going to eliminate it. Okay, now we move to the last number in the array of primes, which is 19. 19 will be multiplied with 1. Alright, so I'm going to get 19. Clearly 19 is less than 26, so it will replace 26. 26 will be eliminated and 19 will take its place as the 9th super ugly number. Now this 19 we got from the final number in the array of primes, so you know very well what we do. In this case we are going to increment this index. We move to finding the 10th super ugly number. We are going to start from here. The value, the index stored here is 6. At 6 we have 13. 13 multiplied by 2 is going to give me 26. So I populate directly 26 in this cell. I don't know why I wrote it over here. We move to 7. We have the index 3 in the corresponding cell. At 3 we have 4. 7 multiplied by 4 is going to give me 28. No way it is less than 26. So 26 stays and 28 gets eliminated. We move to 13 now. Here the index is 2. At 2 we have 2. 13 multiplied by 2 is going to give me 26. Since 26 is already here, hence we are not going to change it. We move to the final value. We move to the final number in the array of primes, which is 19. Here the index is 2. Value at index 2 is 2. 19 multiplied by 2 is going to give me 38. No way it is less than 26. So 38 gets eliminated and 26 stays. Now we got this super ugly number using 2 initially. So this 6 will change to 7. But this 13 over here also gave us 26. Okay, so we will have to increment this index, the index stored in the corresponding cell in the array of multiples, by 1. So this 2 will change to 3. We move to the next cell. Now we'll determine the 11th super ugly number. We will start from here again. 7. At 7 we have 14 stored. So 14 multiplied by 2 is going to give us 28. Let's store 28 directly in this cell. We move to 7. Here we have 3 as the index. The value here is 4. So 7 multiplied by 4 is going to give us 28 again. So 28 is not going to replace 28. We come here, we have 13, the index is 3, value over here is 4. So 13 multiplied by 4 is going to give me 52. And 52 is no way less than 28, so 52 gets eliminated and 28 stays. When we move to the final number in the array of primes, 19, it will be multiplied with 2 because here we have the index as 2. 19 multiplied by 2 is going to give us 38, and this 38 is not less than 28, so 28 stays and 38 gets eliminated. Now we got this 28 using 2 initially, so in that case I am going to increment this index by 1, so this changes to 8. But if you have observed, then when we were drilling this prime factor 7, then we had the index over here as 3, the value was 4, 7 multiplied by 4 also gives us 28. So in that case we will have to increment this index by 1 as well. Alright, so we move to determining our final super ugly number, and the 12th super ugly number was the one that we had to determine as a part of this problem. So this is going to give us our answer. We are going to start from here. The value over here, the index over here is 8. At 8 we have 16. 16 multiplied by 2 is going to give us 32. I put 32 directly in here. Then I move to this 7, the second number in the array of primes. Here the index is 4. At 4 I have 7, so 7 multiplied by 7 is going to give me a big number, which is 49, which is not less than 32, so 49 gets eliminated. I move to 13. Here the index is 3. At 3 I am getting 4, so 13 multiplied by 4 is going to give me 52 again, and that is not something we are going to cherish because it's not less than 32, so 52 gets eliminated and 32 stays. We move to the final number in the array of primes. Here the index is 2. At 2 we have 2. 19 multiplied by 2 is going to give me 38, and it is again not less than 32, so this 38 gets eliminated and 32 stays. Also we got this 32 using this number from the array of primes, which is 2. So in this case what do? We are going to increment the index in the corresponding cell in the array of multiples by 1, so this becomes 9. But we have already got our 12th super ugly number over here, which is 32. With this we have come to the end of this video. I hope you enjoyed learning this problem of super ugly numbers from Leetcode. I hope you found this video interesting and fun. I look so much forward to help you with programming and algorithms. And only for this video, goodbye and take very good care of yourself.